Let's go to the last example. The last example are angles whose vertex lies outside the circle or in the circle's exterior. So once again, you are going to have two intercepted arcs with reference to this angle. And so the angle measure in this is going to be 1/2 the difference of the intercepted arcs. And this is going to work with the following types of angles. It could be two secant segments, which is what's illustrated here. It could be two tangent segments. And so what that's going to look like is this. And in that particular case, you'll still have two intercepted arcs, here and here. And then you might have the final possibility, one tangent segment and one secant segment. And if that were the case, you'd be looking at something like this. In all of those, again, you'd still have your two intercepted arcs as well. Okay, so no matter which of those cases, if the vertex lies in the exterior, you're going to take 1/2 the difference of their intercepted arcs. So again, if we were to identify this as M and N here, the calculation for this is the angle equals 1/2 of the difference M minus N. All right. So let's take a look at how these particular calculations would occur. And I'm going to talk through the first one and then give you a chance to do a couple others. If we're looking for the value M here, we have a vertex or an angle whose vertex lies in the exterior of a circle. So the way that you would set this problem up is the angle is equal to 1/2 the difference of the intercepted arcs. You're always going to start with the furthest arc away. So here's our two intercepted arcs. So the furthest one away is M, the closest one 62. And so what we'll do is we'll plug in our values. So our given angle is 42 degrees, is equal to 1/2 M minus 62. And then we can simplify what we have. Get rid of our half by multiplying both sides by 2. You get 84 is equal to M minus 62. Add 62 to both sides, and you solve for M. So 80 plus 60 is 140. 4 plus 2 is 6. So you get your angle to be, or your arc measure to be 146. Now, if you're somebody who prefers to kind of do this with mental calculations or not write this all out, for you what you would probably do is you'd start with your given angle, double it, and know that that has to be the difference between your other arcs. So if we take 42 and double that, we get 84. So what we need to do is find what number is 84 from 62. Right? Again, you could add those together to equal this as well. So 84 plus 62 is how you get your 146 also. Okay, so see if you can answer these remaining two. Okay, so here we have this arc measure of 178, a closer arc measure that's unknown. We know our angle is 68. So if we take our angle is equal to 1/2 the difference of our arcs, 178 minus M. We can now solve. If we double both sides to get rid of our fraction, we get 136 is equal to 178 minus M. Subtract a 178 from both sides. We get negative 42 is equal to negative M. Change the sign, and we have our solution. M is 42. Okay? Again, it's a straightforward calculation on there as long as you know how the pieces are related. All right, this last one's a little more complicated and it takes a little bit of thinking. You're not specifically told what these angles are, but when you look at it, you should be able to identify what's left for n. And what do we know? We want to express these. If we express them in terms of what's here, we know that 66, our angle whose vertex lies outside the circle, is equal to 1/2 the difference of the intercepted arcs, so m minus an n. Okay, but we have these two variables, so anytime you're given an equation, you need as many equations as unknowns. So in dealing with just one equation, we need to reduce this down into terms of one unknown. Okay, so what is the relationship between m and n? They add up to what? Not 180, but 360, right? So if we say n is, we'll let n stay n, what does this remaining portion out here have to be? 360 minus n, right? It's the difference between 360 and n. So if we were to replace that, so replace m with 360 minus n minus that n, what we can now do is simplify our expression. So here we get 360 minus 2n. Now you could either, in this particular case, you could either multiply both sides by 2. However, if you can distribute and not wind up with a fraction, it'll actually simplify the numbers you're working with. So I'm going to prefer to distribute here. So what's half of 360? 180. And what's half of negative 2n? Negative n. It just gives me an easier number to work with here. And so now, as I subtract my 180 from both sides, I get negative n is equal to, and here I get negative 114. Okay. Change the sign. So my n value is 114, which means what's left for my m value? 246. And so that would be my solution. So if we look at this set here, it's a little more straightforward. You have this inner arc of 21 degrees, this outer arc of 85. So our angle measure is going to be 1/2 of that difference, so 85 minus the 21. If you calculate that through, we get a difference of 64. So half of 64 gives us our angle measure, 32 degrees. The second problem on this, again, same concept. You have an intercepted arc of 140. So what's left for this other intercepted arc? So 360 minus 140, so 220. And so now if you take your x value is equal to 1/2 the difference, 220 minus 140, that has a difference of 80, so half of 80 leaves you with 40. So that gives you your angle measure out front.